Today we're going to learn about the trigonometric ratios. First we need to introduce the idea of trigonometry. Trigonometry is the study of the relationship between the sides and the angles of triangles. Now, we've already discussed multiple times throughout the year that triangles are the most unique shape. And the reason for that is across from every angle is a side. When we did similarity a couple lessons ago, we looked at the difference between a triangle and a quadrilateral. Opposite the angle of a triangle, we could see that there was a side, but opposite the angle of a quadrilateral, there's another angle. And when we have another angle, we saw that there were infinitely many options for where that angle is. It could be concave, it could be convex. Trigonometry, because triangles are unique in this way, it allows us to use the relationship to find unknown sides because of its structure. As you look at this right triangle, we know that it's a right triangle because in the lower left-hand angle, we see the right angle symbol, that perpendicular symbol. We are going to call angle x degrees, our reference angle because it is identified. The other acute angle is not identified. What we're first going to start with is naming the sides of this right triangle from the perspective of our reference angle. So if we're looking from angle x, the two legs are the sides that surround the right angle, and we call the one across the triangle the opposite leg. We call the one that is next to the reference angle, meaning that it is touching it, it is making it up. That is called the adjacent leg because adjacent means next to. And then the hypotenuse is always the hypotenuse. This doesn't change. It's always across from the right angle and it's always the longest side. Right. Now, it's important to be able to identify the opposite leg, adjacent leg, and hypotenuse. So we're just going to take a look at an example doing that, and then we're going to do a you try where I'd like you to pause the video and try it yourself. So we're just going to simply identify the opposite leg with an O, adjacent leg with an A, and the hypotenuse with H from the perspective of the given angle. So if we take a look at the first triangle, this is the upper left. We see where the right angle is. It's always important to note that. So the two sides that make up the right angle are the legs. The hypotenuse is always opposite. If we're looking at x as our reference angle, our opposite leg, we would go across the triangle. Our adjacent leg is next to it, and the hypotenuse is always across from the 90-degree angle. Next, we're going to move across horizontally to the upper right triangle. Again, we're always focusing where is our right angle, where is our reference angle. So our right angle is the bottommost angle, and our reference angle is the angle to the left. So the two legs are the ones that make up the right angle. Hypotenuse is always across from the right angle. So it just comes down to which of the legs is opposite, which of the legs is adjacent. So we go across from the reference angle for opposite. We go next to the reference angle for adjacent leg, and then we go across from the right angle for the hypotenuse. Now I'd like you to pause the video for a few seconds as you identify the three sides of the two remaining triangles. So after you've paused the video and tried it yourself, now let's go over that. So again, our reference angle is that lower left angle for this first right triangle. The two legs are the sides that surround the right angle, and the hypotenuse is across the right angle. So we go opposite the triangle to get our opposite leg. We go next to the reference angle x for the adjacent leg, and then we go across the 90-degree angle for the hypotenuse. For our last triangle, again, the two legs make up the right angle and the hypotenuse is opposite the right angle. We're focusing on our reference angle x, and so we go across the triangle for opposite, we go next to x for adjacent leg, and we go across the 90-degree angle for the hypotenuse. So like I said, it's important to be able to identify the sides of a right triangle given a reference angle. And the reason is our ratios are made up of these side lengths and their proportions, their ratios, which is one of the reasons why we do similarity first, is because we've spent a lot of time looking at ratios and proportions. So the trigonometric ratios are really functions. So it's sine, cosine, and tangent are the three ratios. Sine is spelled S-I-N-E. SIN is the abbreviation that you'll see on the calculator. Now this is a function, which means that there is an input and an output. So if we look at what just popped up on the PowerPoint, we see sine of x degrees is equal to opposite over hypotenuse. So what this is saying is that when we have an acute angle, because in a right triangle, the two angles that are not the right angle are both acute. When we have an acute angle and I apply the sine function to it, we input the angle and we output the ratio opposite over hypotenuse. Now, we've already talked about similarity, and we know that when we have two congruent angles in a triangle, the triangles will be proportional. They'll be similar. And so if we know that one of the acute angles is x and the other angle is 90 degrees, we have angle-angle similarity. So all right triangles that have an x degree acute angle, so say that's 30 degrees, all of them will be similar, which means they will be proportional. So that means that the opposite over hypotenuse ratio will always reduce to the same ratio because they're similar. Okay, next we have cosine. Cosine is spelled C-O-S-I-N-E, so cosine. This ratio, when we input an angle, x degrees, and apply the cosine function, it creates the adjacent over hypotenuse ratio. And then last, we have tangent. So tangent is spelled T-A-N-G-E-N-T. So the tangent of an angle gives us the ratio of opposite over adjacent. So I keep reinforcing the fact that this is a function. You guys have been working with functions for a while now. So if you think about the function, very simple, 2x equals y. The input is x, the output is y. And so when we input x into that function, it is commanding you to multiply by 2. So if I input 5, it would be 2 times 5 equals 10, and our output would be 10. And so this idea of input and output we are comfortable with, but when we do input and output up to this point, we've been doing it with our basic functions, right? It's been multiplication, addition, subtraction. You know, we might have a square or a square root in there, but overall those operations are things that we're fairly comfortable with. Right now we're introducing new, essentially operations, new functions. So when we see sine of an angle, the angle is the input, and the sine function commands you to create the ratio of opposite over hypotenuse. So how does it happen? Well, a long time ago, someone sat there with right triangles and a ruler and a protractor, and they would create all these different right triangles. So they would start off with a right triangle where one of the acute angle was 1 degree. And they would measure the opposite leg, they would measure the adjacent leg, they would measure the hypotenuse, and they would go through, and for 1 degree, they would take the measurement of the opposite leg and divide it by the measurement of the hypotenuse, and they would write it down once they divided. And so if back in the day before there were calculators, there were just tables and tables of information. So someone went through and found all these ratios, and if you wanted to know what they were, you would have to look them up in a book. Now we have calculators that are able to calculate that for us, and there is a separate video that will walk you through how to use the calculator for all of these functions. One of the easiest ways to remember the trigonometric ratios is SOHCAHTOA. So is SOH, sine is equal to opposite over hypotenuse. CA is cosine is equal to adjacent over hypotenuse, so CAH. And TOA, tangent, is equal to opposite over adjacent. So oftentimes when I meet your parents at back to school night, they're like, oh yeah, I remember a lot of geometry. SOHCAHTOA. This is where it comes from. So maybe your parents will be able to help you out here. Remember that ratios are always simplified. So I touched on that at the beginning here when we said that, you know, the triangles are similar and so that the ratios will always simplify to the same value. So when you're looking at your ratios, you always want to put it in simplest terms. So if you get that the sine of an angle is 6 over 8, you're going to want to make sure that you reduce that to 3 over 4. Okay, so let's take a look at these two examples. Our first triangle is triangle ABC. And so here we're going to write the ratios for sine, cosine, and tangent for each acute angle. And so here in the problem you can see sine, cosine, and tangent written out. And so when we look at the abbreviations, we don't say sin and cos and, well, we do say tan, that's okay. But we do say sine and cosine. For the first two. So if you're looking at the first triangle, ABC, if you look at the first column, our focus angle is A. So sine of angle A. So we're thinking of sine is equal to opposite over hypotenuse. So from angle A, I want to identify the opposite, right? So here's angle A. So our opposite is 4. Our adjacent is 3, and the hypotenuse is always across from the 90-degree angle, which is 5. So for sine, we want opposite over hypotenuse, O over H. So we have 4 over 5. Does it need to be reduced? No, it's in simplest form. Next, for angle A, we want cosine. So this is CA. Cosine is equal to adjacent over hypotenuse. So I have A over H, which is 3 over 5. Does it need to be reduced? No, it's in simplest form. Next, we have tangent of angle A. So TOA, tangent is equal to opposite over adjacent. And so here we have 4 over 3. Now, if you take a look here, tangent is more than 1. I want you to think for just a second, is it possible for sine or cosine to be for it ever to be greater than the number 1? So just think about that for a second. Can sine or cosine be bigger than 1? The answer is no, and so we want to think about why. If you take a look at the sine and cosine ratios, in the denominator we have the hypotenuse. The hypotenuse is always the longest side of a right triangle. Therefore, the largest number will always be in the denominator. And since if a bigger number is in the denominator, we always have a fraction less than 1. So sine and cosine will never be greater than 1. So if you were to try and plug that into a calculator where it is bigger than 1, it's going to give you an error. And that's going to be why, is that ratio can never be bigger than 1. Tangent, on the other hand, we can see right here, can be bigger than 1 because there's no limit to which of the two legs is bigger. All right, so now we're going to go ahead and shift our perspective over to angle B. And so from the perspective of angle B, 3 is now the opposite leg and 4 is now the adjacent leg. So looking at the sine of angle B, we do opposite over hypotenuse, which is 3 over 5. For cosine of angle B, we have adjacent over hypotenuse, which is 4 over 5. And for the tangent of angle B, we have opposite over adjacent, which is 3 over 4. So I just want you to take a look at these values and just kind of see where we have things in common. So the sine of angle A is actually equal to the cosine of angle B. And the cosine of angle A is actually equal to the sine of angle B. So I'm going to say that again. So let's take a look at sine of A is 4 over 5. Cosine of angle B is 4 over 5. They're equal. Then we have the cosine of A is 3 over 5. And the sine of angle B is also 3 over 5, so they're equal. And so what we want to take a look at is what's the relationship between A and B? Well, A and B have to add up to 90 degrees. They're complementary. And the reason for that is the triangle sum. Angle A plus angle B plus angle C have to add up to 180. We know that the measure of angle C is 90 degrees, so if I take that away, we're left with the measure of angle A plus the measure of angle B is equal to 90. And so if we had something like the sine of A, say the angle A was 40 degrees, right? That means that angle B would have to be 50 degrees by the triangle sum. And so whenever we have this complementary relationship where they add up to 90 degrees, the sine of one will equal the cosine of the other. And then if we take a look at the tangents, when we have complementary angles A and B, they're just the reciprocal of each other. One is 4 over 3 and the other one is 3 over 4. And the reason for that is they're all part of the same right triangle, so they have the same side length measurements. Okay, let's go ahead and go on to the second triangle. We're looking at triangle PQR. Our first angle that we're going to focus on is P. And so from the perspective of P, the opposite leg is 8, the adjacent leg is 15, and the hypotenuse is 17. So the sine of P is opposite over hypotenuse, that is 8 over 17. We cannot reduce, so that stays. Cosine of angle P is adjacent over hypotenuse, so that is 15 over 17. The tangent of angle P is opposite over adjacent, so that is 8 over 15. None of these can be reduced, but we just want to keep it in mind. Next, we're going to change our perspective to angle Q. So from the perspective of angle Q, the opposite leg is 15, the adjacent leg is 8, and the hypotenuse remains the same, opposite the 90 degrees is 17. So sine of Q, opposite is 15 over hypotenuse, which is 17. The cosine of Q, adjacent is 8 over hypotenuse, 17. And the tangent of Q is opposite over adjacent, which is 15 over 8. Again, we can see this pattern where P and Q are complementary. They add up to 90 degrees. We know that by the triangle sum. The sine of angle P is 8 over 17, which equals the cosine of angle Q, 8 over 17. We can also see that the tangents are reciprocals of each other. This was originally a U-try problem, and if we were in class, I would have you go ahead and do that. But we're going to do it together here. So here we have triangle ABC. We want to find the ratios for sine, cosine, and tangent of these. So we want to ask ourselves, what type of triangle is triangle ABC? And so we see that the two legs, AC and BC, are equal. They are both of length 5, and the hypotenuse AB is equal to 5 times the square root of 2. And this is one of our special right triangles. This is, I thought I had that written there, but I don't. This is a 45, 45, 90, the isosceles right triangle. We know that angle A and angle B have to be equal to each other because their opposite legs are equal to each other. And so that means that when we have the sine of angle A, it's really the sine of 45 degrees. And when we have the sine of B, it's the sine of 45 degrees. And so what we should see is that when we find the sine of A, cosine of A, and tangent of A, that should actually be the exact same as the sine of B, cosine of B, and tangent of B. So let's take a look. If we're focusing on angle A, the opposite leg is the top leg, 5. The adjacent leg is the vertical leg, which is also 5, and the hypotenuse is 5 times the square root of 2. So looking at the sine of A, we have opposite over hypotenuse. So it's going to be 5 over 5 times the square root of 2, which you can see. Now we have 5 over 5. Now 5 over 5 is equal to the number 1, so I can reduce those, right? Cancel 5 and cancel 5. But when I do that, I have to be very careful. The square root of 2 is in the denominator. So it has to stay in the denominator in my next step. So what's in the numerator? Well, we said that 5 over 5 is equal to the number 1, so the number 1 is in the numerator. So we have 1 over the square root of 2. Now, when we were doing our special right triangles, we talked about grammar and how dividing by the square root of 2 without a calculator is extremely hard. So when mathematics was developed and the grammar of mathematics was developed, we never wanted to see the square root of 2 in the denominator. And so we want to do what we call rationalizing the denominator. And so to do that, we want to multiply by a number equal to 1 that will give us a perfect square in the denominator. So I want to multiply by square root of 2 over square root of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is equal to the square root of 4. Square root of 4 is equal to 2. So that's how we get our final answer of square root of 2 over 2. Now, cosine of A, adjacent over hypotenuse, is also 5 over 5 square root of 2. So 5 over 5 square root of 2 reduces to 1 over square root of 2, which when we rationalize the denominator is equal to square root of 2 over 2. Now let's take a look at tangent. Tangent is equal to opposite over adjacent. So the opposite leg is 5, the adjacent leg is 5. 5 over 5 equals 1. And so let's go ahead and go to angle B. So sine of angle B is opposite over adjacent. So opposite leg is that vertical leg, so that's 5. Our hypotenuse is still 5 square root of 2. And so we reduce the exact same as the sine of angle A. And then the cosine of angle B. Cosine is the adjacent leg, which is 5, over the hypotenuse, which is 5 square root of 2. So we see the same thing happening. And then for tangent, opposite over adjacent, our opposite side is 5, our adjacent side is 5, so we reduce to 1 as well. And so what we see here is with a special right triangle, something special happens. So this is an isosceles right triangle, which means that the acute angles are the same. Angle A is congruent to angle B. And when that happens, because the sine of angle A is equal to the cosine of angle B, right, that what we talked about last slide with them being complementary, when they're also congruent, all of them, the sine of A, the cosine of A, the sine of B, the cosine of B, they're all equal. And this only happens in this special right triangle. And then the other thing is tan. Tan is going to equal 1 because our legs are congruent. So that's, again, special right triangles. If you need to review rationalizing the denominator, you want to go on the website for lesson 9.3, chapter 9, lesson 3, special right triangles. Next, what type of triangle do we have here? So here's a triangle PQR. If you take a look, opposite of P, that leg is 9, and the hypotenuse is 18. And so if we were to reflect this over the side PR, the side where 9 is would double, and that would get 18. And so what would happen is we would have an equilateral triangle. So this is half of an equilateral triangle, which is also a special right triangle. So this is that 30, 60, 90. So opposite the smallest leg is the smallest angle. So angle P would be 30 degrees. Opposite the longer leg is the middle angle. So Q would be 60 degrees, and then R is 90 degrees. So what type of triangle is triangle PQR? It is a 30, 60, 90 special right triangle. So if we're looking at the sine of P, we want opposite over hypotenuse. From P, the opposite leg is 9. The hypotenuse is 18, so that reduces to 1/2. So any 30, 60, 90 right triangle, because they are similar, the angle-angle similarity, if the small leg is 5, the hypotenuse would be 10, this would reduce to 1/2. And so the ratio will always be 1/2 when we're taking the sine of 30 degrees. You can plug it into a calculator and you would see that as well. Cosine of angle P is adjacent over hypotenuse. So the adjacent leg is next to, so that's 9 square root of 3 over 18. So 9 over 18, that reduces to 1/2. 1 times the square root of 3 is square root of 3, and then we have that 2 in the denominator. So again, any 30-degree angle, when we take the cosine, will reduce to square root of 3 over 2. And then tangent, we have opposite over adjacent. So the opposite leg is 9 over the adjacent leg, which is 9 square root of 3. So we want to reduce 9 over 9 is equal to 1. We want to make sure that that square root of 3 stays in the denominator for that first reduction. So we have 1 over square root of 3. Then we rationalize the denominator by multiplying both top and bottom by the square root of 3. 1 times the square root of 3 is square root of 3. Square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3, and so our final answer for the tangent of 30 degrees, which is angle P, is square root of 3 over 3. Next, we're going to look at angle Q. So this is the 60-degree angle in this 30, 60, 90 special right triangle. And so we have opposite is the side of the leg, 9 square root of 3. The hypotenuse is 18. We reduce to square root of 3 over 2, which, as you can see, is equal to the cosine of P. We know that P is 30 degrees. We know that Q is 60 degrees. We can see that those are complementary. Cosine of Q, we have adjacent over hypotenuse, so that's going to be 9 over 18, which reduces to 1/2. And then the tangent of Q is opposite over adjacent, which is 9 square root of 3 over 9. 9 over 9 is equal to 1. The square root of 3 is in the numerator, so we have the square root of 3 over 1, or just the square root of 3. Again, if you need to review your special right triangles, how did I know that this was a 30, 60, 90? You need to go on the class website, go to Chapter 9, Lesson 3, Special Right Triangles. If you need to practice rationalizing the denominator, you'll find that in the lesson there as well. So, to summarize, what do we do with trigonometric ratios? Sorry about that. If you have angle measures, you can input the angle measures to find the side lengths or distance using the trig ratios, right? If you have side lengths and you need to find an angle, you can also find it here. Using a calculator, if we were in class, I would be able to pause right now and walk you through how to use a calculator. I did find a YouTube video that goes through how to use a couple different calculators as well as an iPhone to find the trig ratios and use that on your calculator. So you can look at that video. You can pause this video and look at that video now, or you can finish through this video and look at that after. But what we're going to do is just go over a couple of examples on how we would actually use these trig ratios when we have unknown sides. Because that's what we do in math, right? How do we use the rules of mathematics to find unknown parts? And so we want to find the length of the hypotenuse of a right triangle if one of the acute angles measures 20 degrees and the leg opposite the angle measures 410. Now, if that was written out without an image, we would have to create an image. So take a look at the picture below, and that's going to be what you would want to create. So we know that it's a right triangle. First, we see the word hypotenuse, and then we see the words right triangle. So we would draw a right triangle, making sure we label the right angle. We want to find the length of the hypotenuse, which means that that is our variable. So I'm going to go ahead and call that x. One of the acute angles measures 20 degrees, so we measure probably the one we drew smaller, 20 degrees. And then the opposite leg, so we want to go wherever we put the 20 degrees, we want to go opposite and put the 410 feet. So when we're looking at this, which of the trig ratios do we use? How do we know that we're using trig ratios? One of the reasons that we know we're using trig ratios is our problem deals with an angle and two sides. And that's what a trig ratio is. We input an angle, we output two sides, a ratio between two sides. So what two sides are we dealing with? Well, from the perspective of 20 degrees, we're looking at opposite and hypotenuse. So think of SOHCAHTOA, SOHCAHTOA. TOA. So I'm using OH. That is sine. So to set up the ratio, we're going to have sine of x degrees is equal to opposite over hypotenuse. Now let's input the degrees. So it's going to be sine of 20 degrees equals opposite, we know is 410, over hypotenuse, which is x. So I need to solve for x. The first thing I need to do is multiply both sides by x to get it out of the denominator. So we have x times the sine of 20 degrees equals 410. Now remember, the sine of 20 degrees, if you think about it in parentheses, that will become a number. I just have to plug it into a calculator. And so I want to get x by itself. What operation is happening between x and sine of 20 degrees? Multiplication. So I want to divide both sides by sine of 20 degrees. So x is equal to 410 divided by sine of 20 degrees. How do I input that into a calculator? Like I said, there's a video to help you with that once you're done with this video. But for me, with a calculator that I have in class, I would do 410 divided by, I would hit the sine button, I would insert the 20 degrees, close the parentheses, and press enter, and we get about 1,198.8 feet for the hypotenuse. Okay, like I said, after you're done with this video, you're going to want to look at how to input that into the different types of calculators, including an iPhone. Next, we're going to take a look at this triangle here. So a right triangle has legs of length 8 inches and 15 inches. Find the measure of the angle opposite the 8-inch leg. So we draw a right triangle, we do the two legs that are surrounding the right angle, 8 and 15, and then our unknown angle is opposite 8. So that's where we can see that x degrees. And so which of the three trig ratios do we use? Well, we're given the opposite and the adjacent leg. So if we think of TOA, we want TOA, OA. So this is the tangent ratio. So tangent of an angle is equal to opposite over adjacent. Do I know the angle? No, I do not. But I do know opposite over adjacent. So we have tan of x degrees is equal to 8 over 15. Now, here I'm kind of stuck because what's happening to angle x? It's not multiplication. We are not taking x times tangent. That doesn't work. Multiplication only works between two numbers, like 2x, where x is a number and 2 is a number. We can multiply those together, but we cannot multiply tangent times x. That's not what its function is. What is its function? Well, its function is the creation of a ratio. So every function, every operation has what we call an inverse. So if you have 2 times x and you wanted to get rid of the multiplication, you would use its inverse, division, to undo the multiplication. Here it's the same thing. We want to use the inverse of tangent to undo the tangent. But it looks different than anything we've seen before. So the inverse of multiplication is division, the inverse of addition is subtraction, the inverse of a square is a square root. So here the inverse of tan is what we call tan inverse. So how does it look different? It looks like tan, but now it's going to have an exponent of -1. So here what just came up is the tan inverse of tangent x. But what we do to one side, we still have to do the other. So tan inverse of 8 over 15. So if an inverse does the exact opposite, tangent takes an angle and creates a ratio. So the inverse is going to take a ratio and create an angle. So when in the calculator, we're going to do tan inverse. To do that, you're going to press the second button and the tan button. Again, watch the video on how to use the calculator. And we're going to do 8 divided by 15, close the parentheses, press enter, and we get x is equal to about 28.8 0.07 degrees. So like I said, the inverse of tan takes a ratio and creates an angle. Input the ratio, output the angle. The exact opposite of tangent. So if you take a look at what happened on the left-hand side, the tan inverse and the tan, they canceled each other. Just like all inverses cancel each other. Multiplication and division cancel each other, right? Multiplying by 2 and then dividing by 2, cancel the 2's, right? Adding 2, subtracting 2, cancel the 2's. So tan inverse and tangent cancel each other, leaving us x, which is an angle measure in degrees. I know that this is a more challenging concept and quite a bit going on. If you need to go back to the special right triangles to review a little bit, please do that. Please make sure you watch the video on how to use the calculators. And if you have questions, please ask in the Padlet. We're that platform so I can make more videos and walk you through. What might be good is to start the assignment in the textbook, see what you can do with each problem, and as you have questions, ask on that Padlet and I will make a video for every single problem in this problem set if that's what you guys need. So please be proactive with that. Please ask questions, and the only way I can help is to know that you need it. So again, please let me know. Also, if you are interested in this week setting up like a Zoom tutorial or anything, we can do that. I just, again, need your feedback, and if that's what you need, I'm more than happy to do that. Thank you, and like I said, ask questions as you have them.